Something fell from the sky in the middle of summer. Not rain, not hail. Snow. Thick, heavy, blinding snow. In a place where snow had never fallen before in recorded history. Scientists rushed to the scene. And when they tested what had come down from those clouds, some of them went quiet. Because what they found wasn't just strange. It was a warning. This is the story of a snowstorm that broke all the rules. And the truth behind it is far more unsettling than you might think. To understand what happened, you have to understand one simple thing about our planet. Earth has a system. A rhythm. Like a heartbeat, the atmosphere follows predictable patterns. Warm air rises, cold air falls, moisture collects, clouds form, rain comes down. Scientists have studied this system for centuries. They thought they understood it. They built entire civilizations around it. Farming schedules, city infrastructure, disaster planning. All of it rested on one quiet assumption. That the weather would behave the way it always had. Then, one day, it didn't. In July 2021, the city of Moscow watched in stunned silence as snow began to fall. Not a dusting. Not a fluke. A full-scale blizzard dropped several centimeters of snow on a city that was supposed to be experiencing summer temperatures. People posted videos. Scientists scratched their heads. Meteorologists scrambled for explanations. But that wasn't even the strangest part. A few weeks earlier, Death Valley, one of the hottest places on Earth, recorded temperatures that shattered all previous records. And in parts of Canada, small towns that had never seen temperatures above 40 degrees Celsius in their entire history suddenly cooked at nearly 50 degrees. The planet seemed to be sending mixed signals. Summer turning into winter. Deserts turning into furnaces. And scientists were beginning to realize that these events weren't random at all. They were connected. And the connection led somewhere terrifying. There's a river in the sky. Most people don't know it exists, but it controls much of the weather across the entire northern hemisphere. It's called the jet stream, a powerful fast-moving current of air that flows roughly west to east, high above our heads, at speeds of up to 400 kilometers per hour. Think of it like an invisible wall between cold Arctic air in the north and warm tropical air in the south. For thousands of years, this wall held firm. It kept extreme cold locked in the Arctic and extreme heat contained closer to the equator. It was one of the most stable forces in our atmosphere. A guardian of balance. But the jet stream is weakening. As the Arctic warms, and it is warming at nearly 4 times the rate of the rest of the planet, the temperature difference between the Arctic and the tropics shrinks. And when that difference shrinks, the force that keeps the jet stream moving in a clean, straight line begins to break down. The jet stream starts to wobble. It bends. It dips south in wide, sweeping curves, dragging Arctic air deep into regions that should be warm. And in other places, it loops north, pulling tropical heat into areas that should be cool. The result: summer snow in Moscow. Deadly heat in Siberia. A world where the seasons start to blur together and stop making sense. A world where the weather becomes unpredictable in ways that threaten everything we've built. Here's where it gets stranger. Scientists discovered something in the data from these extreme weather events that most news stories never mention. The snowstorms and the heat waves weren't just happening more often. They were getting stuck. Under normal conditions, weather systems move. A storm rolls in, dumps its rain or snow, and moves on. But with the jet stream bending in these long, slow curves, weather systems are losing their ability to travel. They stall. A heat dome settles over a region and refuses to leave for days, sometimes weeks. A snowstorm locks itself over a city and keeps falling long after it should have ended. Scientists call these events blocking patterns, and they are becoming dramatically more common. Think about what that means for a moment. It's not just that the weather is getting more extreme. It's that the extreme weather is staying longer. A wildfire in a region that gets a 2-week heat wave instead of a 2-day heat wave doesn't just get bad, it becomes catastrophic. A flood from a storm that stalls over a city doesn't just fill basements, it wipes out entire neighborhoods. The danger isn't only in the intensity of these events. It's in their duration. and duration is getting longer every year. Now here is the twist that most people never see coming. When we talk about climate change, we usually think of gradual shifts, slow warming, slowly rising seas, a future problem, something for our children or grandchildren to deal with. We imagine a smooth line on a graph, creeping upward. But nature doesn't always move in straight lines. Nature tips. It reaches a point of no return and then flips, sometimes almost overnight, from one stable state to a completely different one. Scientists call these moments tipping points. And the jet stream is dangerously close to one right now. There is a specific temperature threshold in the Arctic. If the Arctic warms past a certain point, the jet stream doesn't just weaken gradually, it collapses into a new pattern entirely. A pattern that has happened before in Earth's history. During past ice ages, the jet stream behaved very differently, funneling extreme conditions across continents in ways that made large portions of the northern hemisphere nearly uninhabitable. If the jet stream crosses that threshold again, we're not talking about more unusual snowstorms and worse summers. We're talking about a fundamental shift in how weather works across the entire northern hemisphere. Permanently. Some researchers believe we may already be closer to that threshold than our current models suggest. A 2022 study published in Nature Climate Change analyzed historical data and concluded that the Atlantic Ocean current system, which is deeply connected to the jet stream, may be approaching collapse in a matter of decades, not centuries. When that study came out, it barely made headlines. But among climate scientists, it caused a quiet, cold kind of panic. Here's the part that should make you pause. Our entire food system is built around predictable weather. The world's great agricultural regions, the American Midwest, the wheat belts of China and Russia, the breadbaskets of Europe, all operate on the assumption that summer means warmth and growing, and winter means cold and rest. When a late summer snowstorm kills crops that were weeks from harvest, it doesn't just create a bad season for a farmer. It creates a supply shortage. Prices spike. Poorer nations that depend on food imports face famine. And when these events happen not once but repeatedly, stacked on top of each other year after year, the system begins to fracture. Not dramatically. Not all at once. But steadily. Quietly. Like a crack in ice that spreads before anyone notices. Some of the world's leading food security experts have already started using a phrase that would have sounded extreme just 10 years ago. Simultaneous breadbasket failures. The scenario where multiple major food-producing regions around the world are hit by extreme weather at the same time, in the same year. It has never happened in the modern era. But with the jet stream destabilizing, the mathematical probability of it happening grows with every passing year. So what do we do with this? The honest answer is, we stop waiting for the warning signs to get louder. That snowstorm in Moscow, those stalled heat waves, the blizzards in places that never had them before, these aren't glitches. They're the system speaking. They're the atmosphere telling us, in the most dramatic way it can, that something fundamental is changing. Scientists have spent decades trying to communicate this through data and graphs and carefully worded reports. But maybe what cuts through is this. The next time you see snow fall in the wrong place, at the wrong time of year, remember that it isn't magic. It isn't random. It is a river in the sky, bending further than it should, and asking the question of how much further it can bend before something breaks. The evidence is already here. The question is whether we're actually listening. If this video made you see the world a little differently today, then you're exactly the kind of thinker this channel exists for. Don't let the algorithm bury the next one. Subscribe now, because the most important stories are always the ones the news cycle forgets too quickly.